Hello.
Yeah, hello.
Good evening, Rakesh. This is Shiva.
Okay, good evening.
Okay. So this session is particularly for the only problem solving or any theoretical.
This is mainly towards problem solving. During problem solving, if there is anything to be clarified, we will clarify.
Oh, okay, okay.
Okay. Yeah.
Yeah, let's wait for a couple of minutes. Let others join, then we can start. Okay, let's start the session. Let the others join meanwhile. So, good evening. My name is Rakesh. I am one of the TA for this Principles of Casting and Technology course, which is taught by Professor Jha from IIT Roorkee. So, this is the live session 3 regarding the casting technology. So, in this session, sir has discussed regarding the gating elements and different types of gating elements and their design, as well as this important aspiration effect in this. So, I will discuss this meanwhile while solving some of the numericals as well as theoretical questions. So, let us start with this first question. So you can go ahead and solve this question, then I will explain after a minute or two. So if you have any doubts, you can keep in the chat or you can directly speak to me. So any answers?
Before proceeding, Rakesh, I have one question actually. This is regarding I gave one suggestion in the first live session itself. Actually, my voice is audible, right?
Yes,
Hello.
audible. Tell me, sir.
Yeah, is it audible, right?
So let me draw this the gating elements. Then we can discuss. Okay. So this question is related to this proof. Okay. So let me read. So which are the following statement is are correct? The first one is the sprues are generally tapered upwards to avoid aspiration air. So this is tapered upward in the sense they mean this thing. This is upward taper and this is downward taper. Okay. Then so that would be the wrong statement. If sprue of uniform cross section is used, severe aspiration may occur because the metal velocity increases as it descends the vertical sprue. If you have seen this lecture, so there is a very good derivation on this aspiration effect. If possible, I will derive at the end. This is the correct statement. The next one is deeper and enlarged base cavity serves as the cushion to the falling weight of the metal and absorbs its kinetic energy. So that is nothing but they are you know describing this thing, and it will also remove some of the high dense impurities as well. Okay, so this would be the correct statements. So that would give option B as the right option. Okay. I hope any doubts. If you have any doubts, you can directly ask or you can keep in the chat also. Okay, let's move to the next question. So if you remember this top getting, so whatever I drew here, this is the top gate. Okay, now you can read. I can simply write in like in this, modify the figure a bit like this. Okay. So they're asking, so which are the following are the advantages of top gating? Since you are feeding the metal from the top, so it is nothing but a top gating system. So any answers before I proceed?
Option A is correct, sir. Option A is correct, sir.
No. Okay. So first option is proper temperature gradients are formed and directions of location towards the riser located at the top of the casting can be achieved. So for suppose if you take this casting, so when you pour, so basically it will fill from in this direction. Okay, whatever it comes, it fills the bottom, and this will be the you know colder zone. Hence, the solidification direction will be upward. Solidification direction. Okay, because this is the heat extraction. Heat flux that is being removed from this direction. Hence, we can obtain directional solidification from bottom to top. Hence, this would be the correct option. And suppose if you treat, suppose if there is any riser here, so if I keep a riser here, and assume it's the risers will be normally it will be of same size as screw or even bigger, and they will be on cylindrical. So now, since the solidification occurring in this direction, it will go. It will be towards the riser direction. So if there is any shrinkage, liquid shrinkage, the riser can supplement it. And if even there is no riser, since the solidification is upward, this screw itself can serve as a riser. So that is what the gates themselves maybe. This is the gate. This is the one gate. There might be several gates if I can keep. They will be serving as the risers. So both the options in this problem are correct. So either I can draw a simple figure with a simple one casting, or I can take a big casting with several in gates and common sprue. Okay. So now these are serving as risers in my case, since the solidification is occurring in this direction. Okay. The central common sprue. Okay, that is what the second statement means. So, so both the A and option B will be the correct option for this case. Okay, this is the advantages I can say in top gating system. We can get the solidification. We can control a bit. Okay. Any doubts? Else we can move to the next question. This is a simple question. I'll give. I can give a shortcut to remember this as well. Any answers? This is very simple. They are just asking directly what is the gating ratio.
Option A.
Hello.
Option A, sir.
Any answers?
Hello, sir. Hello. Hello.
Okay. So okay. So let me explain this gating ratio. So so the diagram will be similar, whatever I had drawn earlier. So we start with a screw, then a runner, and then an ingate. Okay, this is casting. This is gate. This is screw. So we start with screw, then runner, then gate. If you are pouring any metal inside, so that is the order you follow. So similar, the gating ratio also similar. It is the screw area, then runner, then gate. Okay, this is the ratio we follow. Okay, that is this gate area, this runner area, as well as this. We can take this as a screw area. Okay. Any doubts? And it should be a total. If you are using multiple runners, it will be the total area. Hence, A will be the correct option. If you are using it, because in B option they took total only for runner, not for the idiot, so we'll not consider it. Consider it. Just have a look. So this is the shortcut you follow. You can follow the simply direction of liquid metal. In short, we call melt. Okay. We will solve some numericals on the next coming slides as well. So let me move to the next question. So any doubts in the previous question, you can ask. Or else please go ahead with this question. Any answers? Any answers, or shall I proceed?
Answer option C, sir. Hello.
If anyone, I think someone is trying to speak, but I don't hear anything.
Sir, you are not
Maybe there is
hearing
some
anything,
problem with
sir.
the mic.
Hello.
Yeah,
Hello.
so some Govindan, I think there is some problem with the mic. I cannot hear your voice.
Your voice, I am hearing, sir.
Yeah, yeah, now I can hear.
Is it clear now?
Yeah, yeah, it is clear now.
Okay. Option C, both 1 and 2.
Okay, okay. Let's wait. Any other answers? Okay. So, so they are asking for pressurized gating system. So as it keeps, so the first option is as it keeps itself full of metal, the danger of metal pulling away from the walls with consequent air aspiration is thus minimized. This is true. The second is high metal velocities in pressurized system may tend to cause severe turbulence in the junctions and corners and in the mold cavity. This is true as well. So option C will be the correct one. So let me explain what exactly this pressurized gating system is. So I will be drawing this system, uh, this setup so many times in this session. So we have a casting here, we have a ingate, we have a screw, we have a runner. Okay, now if in pressurized system, so there is a term called choke area, which is the minimum area in this entire gating design. So in pressurized gating system, this will be the choke area. This in-gate area, that is gate area, which is designated as AG, will be the choke area. Means that is the smallest area which controls the volume flow rate. Hence, if this is the smallest, so we can ensure that all this part will be full because that is the controlling factor. This is the choke area is the control factor, so all will be the full. So there will be no air aspiration effect since everything is completely filled. Okay, and since we are uh, pushing this metal with very high velocity, with very high pressures, there is a chance, there is a severe turbulence as well as there is a chance that the corners and molar cavity will get eroded. Okay, so hence first option, second will be true. So this is the case of pressurized. Okay, so suppose if the screw area is the choke area, then we can say this as a non-pressurized gating system. So only here it will be the this will be the choke area, and rest will be the area will be more or less bigger. Then I can give so in gating ratio we have screw, runner, and gate. Suppose if I say one is to two, and the other one is one is to two is to one. Okay. The other one is 3 is to 1. So can anyone tell me which between these two, one and two, which will be the pressurized gating system?
First one, sir.
Okay. What about the second one? Actually, both are pressurized gating systems in this case. But I just manipulated in such a way that the screw area is also equal to gate area, but which is the minimum area. Hence, this will be the pressurized gate system as well. Here also, if this is 3, this is 3, and this is 1. Hence, this is the smallest area. Hence, this also will be pressurized. Both will be pressurized in this case. If you have any doubt, just multiply with any constant. So this will be 3x screw area, and this will be 3x, and this will be only 1x. Hence, this is the smallest. So both are pressurized in our case. So you should see this, which are the gate area only. If that is the smallest one, then I can go ahead with the pressurized gating system. Okay. So let's move to the next question. If you have any doubt, you can ask it in between also.
Option B, sir.
Yeah. Sorry. So option B. So since it is unprecedented gauge system, you can directly tick the second option because it reduces the turbulence in the gating system, which is disadvantages in case of pressurized gating system as we discussed earlier. So second one is the correct one. Then we should see the first option, produce high metal velocities, which is the wrong because we are not giving any pressure in this case, and permits lower flow rates compared to pressurized gauge system, which is lower flow rates, which is contradicting. Produce high metal velocities and permits lower flow rates compared to pressurized gearing system, which is wrong in case of unpressurized gearing system, since the metal velocities will be less compared to pressurized gearing system. Hence, option B will be the correct one in this case. Okay. Let's go ahead. So this is also something related to gating ratio. So let me ask you one question. So what is this gating ratio? Pressurized or unpressurized?
This is unpressurized.
Yeah, correct. Since here gate area is less than, sorry, is greater than a screw or a runner. So hence it this will be unpressurized gating system. So this is the logic.
Option A is correct, sir.
Yeah, option A is the correct one. So the logic is we have to follow the belt direction. Screw, then runner, then gate. This is the gating ratio. Screw, then runner, but this will be the total and total in gate area. Okay. So, so this is straightforward question. You can.
Option A is correct, sir.
Yeah, option A is the correct one. So basically, the main purpose of using gate is to feed the casting, but not to give the passes or compensate or avoid cavities. So if you remember, uh, so this is the cast, and this is the gate. So this is just to feed the casting at a constant rate. That's the only main purpose of gate. That's it. Nothing. There is no other purpose for that. Let's move to the next question. So this is the numerical. So we'll be doing numericals from now on. So I think by doing these numericals, we'll get enough confidence to solve these type of questions. I'll give you 2-3 minutes. Just read the question. You can solve and you can. So if you are facing any difficulties, you can ask. I can give some hints for solving. Okay, let me start. So you can carry on. If you have any doubts, you can look at the explanation. So a mold has down screw whose so they have given the length of the screw, that is 20 centimeter, and the cross section area at the base of the screw is 2.5 centimeter square. The down screw feed the horizontal runner leading to the mold cavity. So this is the volume of the cavity. So they have given us gating ratio, the time required to fill the mold cavity. So first we need to know what is the formula for the time required to fill the mold quantity. So that is pouring time. So T is equal to, so we should know the volume of casting divided by, I can say discharge, or I can directly write volume flow rate. So if I take this, centimeter, since here everything is in centimeter, I'll take centimeter cube. So volume flow rate will be centimeter meter per second. So I will get T in seconds. So this is the formula for pouring, time to fill the cavity. Okay, this should be in mind. One shortcut I can say is, this discharge formula is A into V. Okay, and units are centimeter per second. Okay, then so this is the formula. Then uh, see the units. Q is nothing but centimeter cube per second, right? Centimeter cube is nothing but volume divided by second is nothing but time. So time is equal to volume by Q. That is nothing but volume of the casting divided by volume flow rate. That is centimeter cube per second. It looks odd, but a simple way to remember. But this is the straightforward, formula. So no need to worry much. So once we get this formula, now we need to know the so volume of the casting is given. So now we need to find volume flow rate. That is nothing but A into V, and A is gate area, and V, because that is the controlling factor here, and V is the velocity. So in our, if you see, this is the screw height they have given for you as 20 centimeter. So if this is 1, assume this is 2. So if you apply this Bernoulli principle between 1 and 2, if you equate all potential kinetic and datum heights, then you will end up with V2 is equal to square root of 2ght. So from this we can get the velocity. So now we are stuck with gate area. So for that they have given you gating ratios. That is nothing but
5.05,
uh,
sir.
how much? 7.
5.05.
Okay, nice. Okay, that is the we got the velocity. Now we need to calculate this gate area. So in order to calculate this gate area, so we are given with the screw base area. That is, a screw is zero point 0.5 centimeter square, and we have a gating ratio relation is 1 is to 2 is to 1. So 2 times the A gate area is nothing but A screw area. So A gate area is nothing but 0.5 by 2 centimeter square. Okay. Sorry. 0.25 centimeter square. That is the A gate area. Okay. So now we have gate area, we have velocity, that is nothing but square root of 2 into 981 we have to write, since we are taking centimeter square, into height is 20 centimeters. So we get V2 here, we got AZ here. If you keep here, you will get volume flow rate, and you can get the time for it easily. Let me try it neatly. So this q is equal to 0.25 into square root of 2 into 981 multiplied by 20. So we get the discharge, then time is equal to 1000 divided by this q. If you have calculator, you can. If you are facing any doubt, you can ask me. So are you getting same value 5.05 seconds? So any other answer you are getting? Okay.
Hello.
Yeah, yeah.
Sir, regarding this gate ratio 1 is to 2 is to 2,
Yes, yes.
the area at the sprue bottom is 0.5 centimeter square.
Correct, correct.
The area at gating is 2 times of this area of the sprue. That is given in the sum 1 is to 2 is to 2. It is not
Okay,
half.
okay. Yeah, yeah, yeah. Correct, correct. Yeah. Thanks for clarifying.
Yes. Then only you can get this 5.05 seconds.
Okay. Okay. Yeah. Thanks for clarifying. So this will be so zero point 0.5 into 2, that is 1. So 2 into 981 into 20 square root. So this will be 198. This will be, I think, around 5.0 seconds. Yeah. Okay. So let us move then next question. So this is a bottom gate system. Basically, you can do this as a top gating system and just multiply by 2. So you will get, sorry, divided by 2, then you will get the bottom gating system. That's one shortcut we can follow. Or else, if you can remember that formula for bottom gating system, you can directly follow that. So no need to remember the formula as well. So here we just take a strip. I'll just briefly explain how we get this formula for bottom pouring filling time for bottom gate. So we'll take a small strip of DH multiplied by area of the casting AC will be equal to this area of the gate into velocity multiplied by time dt. So at an instant of dt time, so dh will be filled. Okay, this entire term is volume and this is also volume. And now you integrate over. So dh will be 0 to height of the casting, and this will be 0 to this pouring time Tp. And Az will be Az. There will be no change, but V will be square root of this total H minus H casting. Okay. H minus Hc I am writing into dt is equal to 0 to Hc. This will be 0 to Tp dH multiplied by A casting. Okay, if you solve this, let me explain it briefly for you. So in case if you are stuck with this, you can. Okay. So now we have an equation 0 to t integrate 0 to t ag and the square root of 2z h casting h minus h casting hc. Okay, and dt is equal to integration 0 to hc. So the height of the casting, this is the pouring time, into this area of the casting multiplied by dh. Okay, you can rearrange terms before adding this integration before integration. So let me rearrange. So this rearranging will be, you take all the h terms aside. That is dh divided by square root of is equal to az into dt divided by az divided by ac. That's it. We just took this h term beside dh. Now we can directly integrate 0 to t pouring time and then 0 to h casting. So we can take ag by ac out, and tp over integration we get tp only, that is equal to, so here we have we can take root 2z outside. Then if you integrate this 1 by root of h minus hc, you will end up with minus h minus hc whole power 1 by 2 from 0 to hc. So this is the integration that you get. You need to apply hc and h0 here. So if we keep hc minus hc will cancel. Uh, you'll get 0. Then if you keep 0, then you'll get, so this term you will get, you will get 2 here. Okay, you get 2 here. So this is the derivation. So this is the TP that you need to find. Oh, sorry. I think I just made a mistake. This is H, not HC. Yeah. Yeah. Sorry for the confusion. Yeah. So till now, I think you followed. So this is H. I wrote HC. That's the confusion. So this is the H, not HC, because it's a derivating quantity. So that's why it will be H. So now if it's simple. So now you just substitute root by 2z. So minus, we keep hc, then h minus hc, minus into minus plus 0 h, 1 by 2, 1 by 2. Okay. Now you have the formula under root h minus under root H minus HC is equal to AG by AC into TP. So finally pouring time is nothing but 2 times AC divided by AG under root 2Z square root of H minus HC. So this is the formula for pouring time in bottom heating. Okay. So let me copy this formula to here. So that is nothing but TP is equal to A casting divided by A gate, then 1 by 2Z under root into 2 minus square root of capital H minus square root of H minus H casting. Okay. You have A casting. Let me see. You have A casting. You have gate area as well. Then G is given. Then you have capital H means the total height, and you have casting height also as well. So directly the directly substitution, that is A casting is nothing but 500 mm square. So everything is in mm, so let us follow that. So A casting is 500 divided by A gate is 10, 1 by root 2 into G is given as 10 power 4 into 2 into under square root of H is 60 minus square root of 60 minus 50, that is 10. So if you solve, you will get the answer. Anyone with the answer? So I'm getting 3.24 seconds. So can anyone confirm? So any doubt in the derivation or anything? Just you can confirm by chat or you can speak.
3.24 is also correct, sir. I am getting.
Okay. Yeah. Thanks. So let us do this by top gating as well. So in top gating, you just need the 500 into 50, that is the volume, divided by A gate is 10 multiplied by square root of 2Z and height is 60. Let me write G value. G is 10 power 4 multiplied by height is 60. So how much you are getting in top gating?
Sir, what is this one, sir? Top getting?
I'm just calculating same for top gate.
What is the formula for top getting?
It is the same that we did previous. So it is just the volume divided by the flow rate.
Okay, okay.
Yeah. So this formula we are using volume casting divided volume flow rate. This is for top gating. Okay. Because in top gating, so this is the top gating. So we just had a runner and the casting. So we just divided by the volume divided by this discharge. You will get pouring time. But in bottom gating, since it is it is rising from the bottom, so we have different formula for this.
Okay, okay, sir. If it is not
So I am,
mentioned in the problem, what we will do?
if it nothing is mentioned, you can go for top gating system.
Okay.
Yeah. Like in this case, this question they didn't mention anything, so we directly went for top gating. So if you do it for top gating, so I'm getting 2.28 seconds, but in bottom gating you are getting 3.24 seconds. Okay, so which is not exactly double, it is just near to the double. If you
Usually,
do,
usually top getting should be the half of the time of the bottom getting. Is it okay?
okay, yeah, okay,
But it is not coming here.
yeah, here it is coming. If I do uh, 1 by 2, it is coming 1.62,
Yeah.
which is not exactly the correct in this case. So that is the reason we need to remember this formula for bottom gating system. But in the question, if they give like take twice, you can directly take.
Sir, in this sum, they are not mentioned, but the figure is given as a bottom getting.
Yes, yes, correct.
That's why the answer is 3.24.
2.4, yes, correct.
Yeah. Okay, right.
3.24 is the correct answer. I'm just checking if we do for top gating, how much it will come. It's not exactly the half, it is more than half.
Yes, sir. Okay.
So if you don't remember this formula in exam, it is very quick process. I just explained in this here. It's very quick process. You just have to remember this, volume. Just do a simple integration. So this is like 1 by square root of some c minus x integration. So that you will end up with minus c1 x whole power 1 by 2. Okay, if you do integration of this, that is what I wrote here. Just apply the limits and you will apply and rearrange a bit and you will get this. No need to remember it if you do this derivation, simple derivation. Okay, so let us move to the next question.
Sir, 1 second. That previous problem show me, sir.
Yeah.
Okay, sir. Let me go for
Okay.
next.
So this is continuation to the first question. So what happens if the mold cavity height is changed to 40 mm? The time required to fill the cavity will be. So in this figure, I will draw the figure for you. Okay, and rest is same. So now in this same question, what happens if you change the height to 40 mm? Take 2 seconds. Let me write the formula. So T pouring in case of bottom, A casting divided by A gauge.
2.3 seconds, sir.
Okay, just cut it off. 2Z 2 times H minus HC. Everything is similar, just we just change this HC value to 40. So it should be less than 3.24. The only option we have is 2.3 here. Because the height is less, TP will also be less. So if height is less, so this term will be more, hence this total term will decrease. That reduces the TP. Okay, I think this is straightforward. Let us move to the next type. Let me know if you have any doubts in between also. So this is something regarding aspiration. So this you can answer only if you know what is this aspiration effect and what is the condition we need to follow. Then only we can answer this. So anyone remember the condition for aspiration effect? So this is the condition for aspiration effect. And we have everything here. So if you see a downspout of 180 length, okay, length has a diameter. So we have diameter, so we have this screw area. The liquid metal is pouring cup in maintained up to 60 cup into the pouring cup is maintained up to 60 height. That is HC. Uh, the diameter of the downspout. So this is what they are asking, and we have this as well. That is nothing but 180 Let me draw the diagram. Then we understand. So here we have given this as 180 and this is 60 and we have the diameter at the top end. That is this we have. We need to find AG, and this is the rule for aspiration effect. So that is nothing but square root of HC is nothing but fifty. So if you do this, you will get D. This is not casting height. This is the pour height. What is the pouring cup height? I am getting around 15, I can say. So anyone, any what is the answer for this? Like if you want, I can explain this screw. What is this? Condition for this aspiration effect also.
Sorry, area of gate. What is the diameter of gate?
So that is not given. That is what we need to find. So here in this case, this screw and gate both are same. That is
How we
what we
can
need to find.
how we can assume that one?
What?
No, no. See the area of gate. To find out the area of gate, we are not given this diameter of gate.
Yes, yes.
Then how we will find out area of gate?
So actually, in this case, I have given the diagram here. So you can, even if the diagram is not given, so this is if there is, so the condition will be, so the pouring cup height divided by the total height under root should be equal to area of the sprue divided by area of the sprue on the lower end. In this case, it is Ag. Like while deriving this derivation, we took this diagram as the basis, so that's why I gave Ag. But this will be the lower end. That is
What is
nothing
the
but
D
this.
value? What is the D value here?
Uh, so that is what we need to find.
Okay, then what is
The
DS
diameter of the
at
down
the
sprue at its lower
at
end.
the denominator?
So this denominator is nothing but the upper end diameter. The diameter of 20 mm is at the top end.
Diameter of
This
a sprue.
Yeah, at the top.
At the top.
Yeah.
Okay, okay, okay. So that's why you are taking it as a 20.
Yes, yes.
Oh, diameter top. You are taking it as 20.
Yes.
Okay. Okay, right, sir. Right. Sir.
Okay. I will briefly explain this aspiration effect. You can watch the lecture video for detailed explanation. So let me see. So initially, so this is. Let me take 2 points, 3 points, 1, 2, and 3. One is at the atmosphere, and two is at the junction of this pouring basin and the sprue, and third is the junction to the ingate. That is the sprue bottom area. So now, if you apply, so everywhere the pressure at all these points should be atmospheric. In contrast, we take P3 should be atmospheric, which ensures that all the above pressures will be atmospheric, or even more than atmospheric is fine. But if there is any less than atmospheric, so there will be a vacuum pressure, so that the air can be sucked into the gating system. So that is what we need to avoid. So P3, if you take this P3 point as atmospheric, that ensures that everywhere it is the positive pressure, so there will be no this aspiration effect into the gating design. So if you apply this Bernoulli's principle, uh, I'll tell you in short. So if you apply this see, in this case, we also need to ensure one more thing. That is, if you take this type of sprue, which is cylindrical, if you take a continuity equation, A1 V1 is equal to A2 V2. Okay. So now, if I take this Bernoulli's equation, uh, bit, between point 2 and 3, so it will be GH2 plus P2 by density plus B2 squared by 2 is equal to GH3 plus P3 by rho plus B3 squared divided by 2. I am neglecting all the losses and everything. Then, so GH3 will be 0. V2, V3 are equal from the, since A1 and A2 are equal, so V1 equal to V2. So we'll get V2, V3 will get cancelled. So if you see, P2 is P3 by rho minus GH2. Okay, and if you take P3 as atmospheric, that is zero atmospheric, which we take in gauge as zero, so P2 will be minus rho g H2, so which is negative. Okay, so now since it is negative, which is not, we cannot use cylindrical. This is happening only due to this continuity equation, that is a1 v1 is equal to, so in this case a2 v2 is equal to a3 v3. So if a2 or a3 are equal, then you are getting a negative pressure at P2, so which can attract gases into the system, which we don't want. So that's why we generally consider a2 or v2 are not equal to a3 v3, and in this equation, so in this equation we cancel out P2 and P3, assuming they are atmospheric, so we just cancel P2 and P3, and H3 will get cancelled. So we have GH2 plus V2 squared by 2 is equal to V3 squared by 2. Okay, and we use, and we have A2 V2 is equal to A3 V3. And if we solve this, so we end up with the equation that this equation, that is what I used in the question given. So that is nothing but ratio R. Okay. If you simplify this and this both equations, we end up with this ratio under root HC minus H is equal to H A3 by A2. So this H3 and HC is nothing but, okay.
Yes, sir.
So this is what you need to remember for the condition as the aspect, because in the question they have mentioned to avoid aspiration.
If by solving this, I am getting this diameter 14.14 mm.
Yes, yes. So we round up with to the next figure, that is 15.
Okay, okay, right, sir.
So now if you see this diameter at the upper end is 15, and the diameter at the lower end is, sorry, upper end is 20 and the lower end is 15, which uh, which is not a cylindrical, rather than some tapered shape downward. So, okay,
Yes, sir.
so we can solve one more. Yeah, carry on. How much you are getting for top? Top is straightforward. So everything is given in inches, so no need to worry. So top is very simple. So we have given 20 into 10 into 5 divided by screw height is 5 inches and area is 1 inch square, that is area, that is 1 inch square into square root of 2 into g is 386 into 5. Okay. So I'm getting 16.09. I think this should be second square. Okay, this is for top. Now see, this is the dimension given, so we need to draw the shape of the casting. So 5 is this, L into B into H. Then we can take any one. This has 20 and this has 10. Because this is we are doing because we need the area of the cast, that is 20 into 10 inch square in this case. Then okay, now we have the screw height, that is nothing but 5, and its area. So in 14 times in bottom is a casting divided by a gate 1 by root 2z 2 times. Okay, so in this case this is 0 because the casting height and screw height both are equal. So then we have a cast by a gate so this is the formula. So a cast is 20 into 10, a gate is 1, so capital H is total height is 5, 2 into 386. So I am getting 32.19 seconds. So can anyone confirm these values?
Yes, sir. Correct.
Yes. Yeah. Hello. Yeah. Anyone with the answer? So there is some nice takeaway from this question. Okay. Let me tell the takeaway. See, if the casting height and the screw height are equal, so you are ending up. So this is the formula, right? So that is not. I will just write. So you are getting 32.19, which is just the double the top gating system, or bottom half of the bottom gate is the top gating system you are getting. So if you in this question, so that is AC divided by A into 1 by 2Z into root H we have. So multiply by root H in the bottom as well as in the denominator. So you will get AC into H is nothing but volume of the casting. Then in the denominator we have AG into root 2GH, nothing but the velocity. We have a factor 2 here. So that is the takeaway. It's nothing but twice the uh, whatever we calculate in the bottom gating system, top gating system. So we end up with 2 times T top because we are having a factor of 2 here. That is this. That is the main takeaway from this question. Okay.
32.83 seconds, sir. It's okay.
Yeah. Okay. Let's move. So for the same question, just calculate using uh, particulate gating system. So this is simple. Particulate gating system is nothing but it is in between. So the gate is here. Okay. So this height will be exactly half 2.5. This is 2.5. This is 5. This is 1, and this will be. Okay, I think I gave everything. Yeah. So for this type of questions, it is exact. So till here we calculate as so here. So T pouring in parting is equal to T pouring in top plus T pouring in gate. Sorry, bottom. So till this height, this is T bottom. From here to here, sorry, reverse. So this is T bottom, and this will be T top. The rest is same. Same. So actually, we convert this problem into two. So one is this one, and the other is this problem. But just the height is 2.5. Here height is 2.5, and the rest everything is same. Okay, so this is bottom and this is the top. So this actually this value should lie in between top and bottom gating system. So here we need to take care these values. Okay, I hope you are getting 17.46 seconds. So if this is less than 32, which is in uh, bottom gating system, and 16 top gating system. So these are the main models in this gating design and area. So if you are perfect with these things, I think you are good to go with the numericals on this gating design. Okay. So shall we move to the next question? Still doing this question. Shall we move to the next question?
Yes, sir.
Okay. So I think this we already done. Just a second. Okay. We can go with this. Okay. Yeah, we are good to go with this question. This is question number 12. This is 14. Yeah. So we don't need to draw the diagram as well in this question. We can directly proceed. So we have dimensions. So let us so the first question is find the time taken to fill the mold. So assuming top top gating system, because in the second they asked it separately for bottom pole. Okay, so in top, so we have volume that is 60 into 30 into 14 centimeter cube. So we have 14, that is area of the gate is given as 6 centimeter square. So this is the top. Similarly bottom, 60 into 30 divided by 6, 1 divided by 981 into 2 times. Okay, it is just twice. So we don't need to calculate as well, because in this case the height of the sprue and the height of the casting are both are same. So if we get top, it is bottom is just twice the top. So I'm getting 25.34 seconds. This will be, this is the just some other example, just the same model. Let me know if you are getting 50.6 seconds. So are you getting 50.6? So shall we move to the next question? So I can give a shortcut for this aspiration effect to remove that formula. Hello. Yeah, very. Um, I hope it is clear. I'm moving to the next question. So that is 15. So in this, so they are asking. this diameter D3 without avoiding aspiration, and everything is given in the question itself. Okay, so we need to know that formula, that is the ratio, or we don't know some, we just remember some h, some a by a. So this is how it looks. I think reverse. Yeah, I think. Yeah, this is how it looks. Now, if you are confused with these areas, so it is simple, mathematics. So this is the pouring cup that you should remember, and this is the total height from the base. That is pouring cup height minus plus screw height. So this value will be less than 1 because the bottom is higher. So in the right side, so if here it is given 2 and 3, since 2 should be more, it should be on the denominator, 3 should be less, it should be on the numerator. That is one uh, you know possible way to remember this. And then the question is straightforward. So we have everything here. We have HC, we have this directly given HS plus SC, and A3 is given. A3 we need to find, and A2 is given. So this can also be written as pi by 4 dt square divided by pi by 4 d2 square. That implies so I'm getting 15.2 mm. So I can round off to 16 mm. Okay. Any doubts? This was 240. Okay, sorry. This is 240. So it will be 6 ones, 6 fours. So it will be 4 power 1 by 2. It is 14 point, so we can take as 15. So this will be 15. So are you getting 14? Sorry, 15 mm as D3. So if you have any doubts, you can ask. So these are the basic models. If you are thorough with this, you can easily attempt whatever the question comes from this gating design. Okay. So all the questions are related to the same. So if you have no doubt, we can end the session. Thanks for attending.
Hello, sir.
Yes, yes.
This lecture class notes, how we can get?
So there was one. I think you might have got a mail from this NPTEL team for
Okay.
recordings.
Okay.
If you click on the recordings, you will get a spreadsheet, Excel sheet in which everything is written, like date wise, what is the recording, and there will be one more section, the folders, the material. So in that you can get these things.
So everything will be there.
Yes, yes. In that Excel sheet, everything will be there.
Okay, right, sir.
Yeah. Thanks for attending. So if there are no questions, we can end the session. Any questions? Okay. Yeah. Thanks.